Alright, so here we have a piecewise function stating let f of x equal, all that stuff. So basically what this question is asking for, I forgot to write it down, my apologies, but it's asking for what values of a and b does it make the entire function continuous. So first of all, what we have to do is find the left-hand limit of 1 and the right-hand limit of 1, set them equal to each other, and then do the same thing for 2. So as you can see here, we're starting off with the left-hand limit of 1, and the corresponding function for that would be x squared minus 1 over x minus 1, x going to 1 to the left side, from the left side of course. And then to further evaluate this, we have limit x coming from the left side of 1. We factor out the expression on the top, which is going to give you x plus 1 times x minus 1 over x minus 1. The x minus 1's cancel out, so that's going to leave you with limit going to x from the left side, x plus 1 over 1, or just x plus 1, as shown right here. Now, since you can see that there are no restrictions to this, you can apply the limit as shown here, which is going to give you 1 plus 1 over 1, which is just simply 2. Now, I highlight 2 because we're probably going to need it for the future. It's an important value in this case. So now it's time to evaluate the limit of 1 coming in from the right side. So we get limit x going to 1 from the right side, and we find the corresponding function for that, which is going to be ax squared minus bx plus 3, because x is greater than or equal to 1. It's coming from the right side. So we get ax squared minus bx plus 3. And then since there are no restrictions to this either, we can just immediately evaluate the limit. So basically what you have to do is just plug in 1 to the x's, as shown, plus 3. And that's simply going to give you a minus b plus 3. So after you get that expression, what you want to do is, since to make the function continuous, the left-hand limit has to equal the right-hand limit, you're going to want to set a minus b plus 3 equal to 2. So as you can see here, the left limit must equal the right limit. So then you get a minus b plus 3 is equal to 2. And you basically just isolate a and b. So you're left with a minus b is equal to negative 1. And I also highlight that because that is very important for the next steps in this question. Alright, changing the color, we're going to start with 2. So we're going to evaluate the limit x going to 2 from the left side. So we need to find the corresponding function. So we look at our functions, and it turns out, since x is coming in from the left side, is going to be less than 2, so x must be less than 2. So we're going to use ax squared minus bx plus 3 once again. And like in the previous part, since there are no restrictions, you could just immediately evaluate this limit by plugging in 2 to all the x's here. And that's going to leave you with 4a minus 2b plus 3, as shown. And once again, this is another important equation that you need to remember. So, keep track of those as I'm doing here. I'm highlighting them, and you'll see why later. So now that we have the left-hand limit, we need to get the right-hand limit. So limit x going to 2 from the right side, f of x. We got to find the corresponding function for this as well. So we go back to our piecewise function. And it turns out that we need to use the equation 2x minus a plus b. So let's go write this down over here. So we get 2x minus a plus b. Once again, there are no restrictions. So you can just immediately evaluate the function as shown. So 2 times 2 minus a plus b, which is 4 minus a plus b. And once again, you have another important piece to your puzzle, I guess. So once again, you have to remember for the function to be continuous at all points, the right-hand limit must equal the left-hand limit to be continuous, of course. So what you want to do is you equal both of these expressions or equations to each other. So 4 minus a plus b equals 4a minus 2b plus 3. And you're basically just going to want to isolate the a and b to one side and everything else to the other side. So as you can see here, we move the a and b to the right side. So plus a minus b. So we're left with 4 equals 3a minus 3b plus 3. I'm sorry, 5a minus 3b plus 3. I'm not sure if that's what I said. So once again, you can move the 3 to the left side. Do that by subtracting. Then you're left with 5a minus 3b equals 1. And once again, you have another important piece to your puzzle. So you highlight that. So now that we have kind of the limits for 1 and 2, we are able to set up a systems of equations with both of these equations. That's why I highlighted them to keep track of them. So we can set up a system of equations. So 5a minus 3b equals 1. And then below it, a minus b equals -1. So you can cancel out whatever variable you want first. It doesn't matter. But here I'm going to cancel out the b first. And we do that by multiplying the whole equation on the bottom by -3. And by doing so, that's going to give you, well, we rewrite the top equation, 5a minus 3b equals 1. And then when you multiply the entire bottom equation by -3, you get -3a plus 3b equals 3. As you can see here, we can cancel out the b's. -3b plus 3b is 0. And we're left with 2a equals 4. And to get a by itself, divide both sides by 2. And that gives you a equal 2. A is equal to 2. Now, to solve for b, you can simply just plug in a to any equation here, any equation that's highlighted. Once again, that's why I think keeping track of those equations are important, just to kind of know where you're at. So here, I decided to plug in a into 5a minus 3b equals 1, as shown. So 5 times 2 minus 3b is equal to 1. That's gonna give you 10 minus 3b equals 1. Now you subtract 10 from the left side and the right side. That's gonna leave you with -3b equals -9. Divide both sides by -3. And you have b is equal to 3. And those are your two answers. So a equal to 2 and b equal to 3 is gonna make the function continuous everywhere.